a special case of greatest common divisor for this exercise because I want to introduce a new definition. I've chosen number 26, 81, 98. So let's follow the same pattern as usual. Let us factorize with prime numbers these three numbers. So we arrange three vertical lines. We write on the left hand side the numbers we want to factorize. Let's start from 26. 26 is an even number. That means we can divide it by 2. Let's do that. 26 divided by 2 is 13. Write the result here on the left. 15 is a prime number, can only be divided by 1 and itself. So let's divide it by itself. And 13 divided by 13 is, of course, 1. Pretty short factorization. Therefore, you can write 26 as the product of all the numbers on the right hand side. It's 2 times 13. Perfect. Let's move on to the next number to factorize, which is 81. We notice that the sum of all digits is 9. 8 plus 1 is 9. Therefore, it can be divided by 3, because 9 is a multiple of 3. Let's write 3 here. 81 divided by 3 is 27. You know from the multiplication table that this number is a multiple of 3. And also notice that 2 plus 7 is 9. Again, a multiple of 3. Therefore, let's divide by 3 again. 27 divided by 3 is 9. 9 obvious multiple of 3, so let's divide by 3 again. The result is 3, prime number, divided by itself. And we're done with factorization. And we write it down here. 81 can be written as 3 times 3 times 3 times 3. 4 times. Therefore, using the power rules, this is equal to 3 to the power of 4. Perfect. Last number to factorize is 98. 98 is an even number, last digit is even, so we can divide by 2. 98 divided by 2 is 49. And from the multiplication table, we know that this is a multiple of 7. So let's keep it short. 49 divided by 7 is 7, prime number. We divide it by itself. 1. Okay, we have reached the result that 98 can be written as 2 times 7 times 7, which can be shortened in 2 times 7 to the power of 2. Okay, we have all the ingredients to cook our greatest common divisor. Let's start with number 2. Number 2 is absent in the factorization of 81, even if it's present in the factorization of 98. But when we calculate the greatest common divisor between 3 numbers, we have to pick numbers that appear in every factorization, all 3 at the same time. And this doesn't happen for 2, because 81 doesn't have that, so I can't pick 2. Let's move on to 13. 13 is present only in the factorization of 26. So again, we have to exclude that for the greatest common divisor. Let's see 3. We have 3 to the power of 4. No other number has 3 in their factorization. So it's easy to exclude that for the greatest common divisor. Let's examine 98. Factor is 2. But again, we have the problem that 2 doesn't appear in the factorization of 81, even if it's in the factorization of 26. Again, it must be a common factor for all 3 at the same time. And the requirement is not satisfied for 2. 7 to the power of 2, again present only in 98, we cannot pick it. Okay, we failed in finding a common factor between the three numbers. What does it mean? Well, it means that the greatest common divisor is the simplest one you can think of, which is 1. And this is a special case when the greatest common divisors between two or more numbers is 1. It means that the numbers are co-prime with each other. It's a definition. You can write it here. Co-prime. And I want to underline a thing, that 26 and 98 are not co-prime with each other, but we are considering all three at the same time. And all three at the same time, they are all three co-prime with each other. Therefore, the greatest common divisor is 1. Okay, perfect. We have examined the juiciest part of this exercise. Now, let's move on to the lowest common multiple. So, again, we're going to use the factorization we've already executed on the left. Write again, 26 is 2 times 13, 81 is 3 to the power of 4, and 98 is equal to 2 times 7 to the power of 2. For the lowest common multiple, we're not so picky. We're going to pick both common and non-common factors, so long they are with the highest exponent. So we start with 2, it's present both in the factorization of 26 and 98. We have to take the highest exponent. They both have 1 as exponent, so it doesn't matter which one we pick. We can pick it only one time, of course. So I pick it from here. Okay. Then we have 13. 13 is present only in the first one. As we have said, in the lowest common multiple, we take everything, common and uncommon. So let's pick 13. Same reasoning for 3 to the power of 4. We have no other 3 to consider, so it's automatically the highest exponent available. And then we have 7 to the power of 2. Alright, now time to calculate the lowest common multiple. 26, 81, and 98. We have to multiply all these numbers I circled in red. 3, take them in this order. Repeat, doesn't matter the order you're gonna pick them. Multiplication is commutative, so we can pick them in any order. And I hope you can pardon me if I use a calculator, because that's a pretty big number. So 3 to the power of 4 times 7 to the power of 2 times 13. We obtain the number 103,184. Alright, this is our lowest common multiple, which is a pretty big number. And that's a pretty common situation when we consider the lowest common multiple of co-prime numbers. It's kind of quite common to get a big number for the lowest common multiple. Well, that's all. The exercise is concluded.